In this video, we're going to learn about conditional probability, learn how to calculate conditional probability, as well as what two-way tables are and how to use them. All right, so conditional probability is the probability of an event A happening given that another event B has already occurred. Formula for this is going to be this formula. We can insert the word "and" here. And this would read like this: the probability of A given B, so this is given here, the probability of A given B is equal to the probability of A and B, which is this part here, divided by the probability of B. Now this is a formula that you're going to want to write down. I'm going to explain it as we do some examples here together. Let's go ahead and take a look at this first example. I'm going to use a Venn diagram along with the formula to help explain this one. So in a group of 100 students, 40 are taking algebra, and 30 are taking biology, and 20 are taking both algebra and biology. So if a student chosen at random is taking algebra, what is the probability that he or she is taking biology? So first of all, a picture of what's going on here. We're going to have a Venn diagram with, let's say that in this circle we have everybody who is taking algebra, and in this circle we have everybody who is taking biology. And we know that there are 20 that are taking both algebra and biology. So there's got to be 20. There's got to be 20 right here. But there are 40 students who are taking algebra. So if we already have 20 in this part of the circle, that means there's got to be 20 outside of that intersection of those two circles. The other thing that we know is that there are 30 people taking biology, and we already have 20 in the circle. That means that there has to be 10 outside of the circle. And so if we just look at the Venn diagram and try to figure this out, the probability of, let me see if I can write it using the terminology here, the probability of A given B. If I rewrite this sentence here, it says a student chosen at random, the given is that they're taking algebra. What is the probability that he or she is taking biology? So the probability of a student taking biology given that they're taking algebra. That's what we're trying to find. Well, we know that there are 40 people taking algebra. Okay, so that's the probability of event B. So if we remember this formula here, the probability of A given B is equal to the probability of A and B. Well, I can only see half of what I'm writing here, over the probability of just B. So the probability of B, that's the probability of somebody taking algebra. There's 40 people here because I have 20 here and 20 here. So then I want the probability of people taking both. Of these people, of the 40 taking algebra, there are 20 that are taking both. So that is equal to 1/2. You can see how this formula works here. This is the probability, this is your total, your new total amount, because that's the given. Given, we're only talking about those people that in this case are taking algebra. And so of those people that are taking algebra, we know that 20 of them, which is half of them, are also taking biology. Okay, so the probability is 1/2. Let's take a look at a different situation. This is a frequency table, and what we have here are males and females, and whether those people have a high school diploma or a bachelor's degree or a master's degree. This is called a two-way table because it's breaking things into two different categories, male and female, and then what type of degree they have. So the first thing that we would want to do here is fill in the missing numbers. Like for example, I know that if here I have a 6 and this is a 3, I know there has to be a 3 here, because if there are 6 total people with master's degree and 3 of them are females, the other 3 have to be males. That should also mean that if I take 16 plus 46 plus 3, I would get 65, and hopefully that's the case. I'm going to check that on my calculator just to make sure. If I take 16 plus 46 plus 3, that does give me 65. So I know I'm good in this row here. Then I can maybe figure out what this one is, because there are 46 males with a bachelor's degree and 51 females with a bachelor's degree. And if I add those together, that's going to be 97 people with a bachelor's degree. The other thing that I can figure out is maybe what goes here, because I have a total of 28 people with a high school diploma. 16 of those people are males. Well, that would mean that 12 of them have to be females, because 16 plus 12 is 28. And then I can find out what these totals are here, because I can take 12 plus 51 plus 3. That's going to give me a total of 66 females that were in the survey. And if I take 66 plus 65, that's a total of 131 people that were surveyed. 66 were female, 65 were male. And of those 131 people, 28 had a high school diploma, 7 had a bachelor's degree, and 6 had a master's degree. This would be 97 here, though. Must have went away. Can't get it to stay. There we go. And 28 plus 97 plus 6 adds up to 131. So there are 97 with a bachelor's degree. All right, next thing that they're going to want us to do here is to find the probability that you have a bachelor's degree given that you're a male. So we're only talking about the males. I'm only interested in this row. And how many males do I have? Well, 65 of them. And that's the probability of B. So what I want is the probability that you are a male and you have a bachelor's degree. Well, that's 46. So the probability that you have a bachelor's degree given that you are a male is 46 out of 65. And if we took 46 divided by 65 and wrote it as a percent, that would be, if we round it up, that would be 71%. If we look at a different one, here we're asked to find the probability that you're a female given that you have a master's degree. So now we're only interested in people with a master's degree. That's 6 people. So that's a total of 6 here. And how many of those people who have a master's degree are female? Well, that's 3. And that's 50%. So that's some examples of conditional probability. Let's just take a look at another problem here that's going to lead into our last problem. There's 4 examples in this video, and this is number 3. What is the probability of a couple having 2 girls if we know that the oldest child is a girl? Well, this is really not conditional probability, and the reason why it's not is because the youngest child isn't dependent on what the first child was. There's only 2 options for the youngest child, and that is to be either a boy or a girl. It doesn't matter if her older sibling is a boy or a girl. She has a 1 in 2 chance, or half the chance she's going to be a girl. It doesn't matter if you come from a family of 10 boys or 10 girls or 5 of each. The probability is always going to be about a 50-50 split. That's the theoretical probability. Now, experimental probability is going to be different. But the answer to this question is a half. Take a look at this challenge question. And if you're here, if we're doing this in class, we're going to just stop and see if we can figure this out in groups. But if you're not in class and you're doing this, see if you can figure this out on your own first by pausing the video and thinking through it, and then starting the video to see if you're correct. Hopefully you've done that. I'm going to display the answer here first. The answer is 1/3, which is surprising to a lot of people. Let's go ahead and dig in and see if we can figure out why. What is the probability of a couple having 2 girls if we know that at least one of the children is a girl? Well, here's what we know. We could have 4 different situations happen. We can have a couple having 2 kids, and the first one's a boy and the second one's a boy. We could have a boy and then a girl. We could have a girl and then a boy. Or we can have a girl and then a girl. And I believe those are the only options that we could have for having two kids. You either have two boys, you either have two girls, or you have one of each. And if you have one of each, the boy could be the oldest and then the girl, or the girl could be the oldest and then the boy. So it says, what is the probability of a couple having two girls if we know that at least one of the children is a girl? Well, that rules out this possibility, because there not any of the children would be a girl. So we know that at least one of the children is a girl, but we don't know if it's the oldest one or the youngest one. So there's a possibility of three things occurring here. And so I could be in this situation, or this situation. We want to know, of those three situations, what is the probability of a couple having two girls? Well, how many of those three situations have two girls? Well, that's only this one here. And so that's only one out of the three different situations where there could be three girls. And so if we did the probability of B on the bottom, that's given that they have at least one child. That's 1/3, or that's three different options that could happen. And of those three different options that could happen, only one of them are two girls. So the probability is 1/3. It's just an interesting problem because it's different than what a lot of people would have anticipated. So anyway, hopefully that made sense. This is assignment number 4 on conditional probability, and we will see you tomorrow in class.